Okay, so for this video, we are going to discuss about the vector equation of a line. Alright, so if you look at the learning outcome 8.4, so to understand the significance of all the symbol used when the equation of a straight line is expressed in the form of r equals to a plus tb. So maybe for your information, r, a, and also b are all vectors. Alright, so t is a scalar of a number. Okay, so this is the learning outcome for this video. Alright, so in short, actually, we want to get the vector equation of a line. Okay, and this is something slightly new to most of us. Alright, I'm not sure whether for those who are from O-level, you learned this before or not, but for SPM students, I don't think that you learned this before. Okay, so it is something new. Alright, okay, so maybe before we go into the vector equation, for this one, for this part, the keyword will be the vector equations. Okay, so before we look at the vector equation, let's have a look for recall back some very basic idea first that we learned before. Okay, let's say I'm having a straight line. So this is a straight line. Okay, and then this is a point on the line that I know the coordinate. Let's say it is 1 and 2. Let's say 1 and 2. Okay, and then let's say the gradient is m. Okay, sorry. So the gradient is m. Okay, so when you want to get the equation for this straight line, the red color straight line, generally it is y equals to mx plus c, right? Okay, so the final answer for us to have is y equals to ms plus c. But to get the value of c, you need to substitute the value of a, the coordinate of a into the equation and also the gradient to get a c. Then eventually you'll get the equation, right? Y equals to something x plus a number. So that is what we have for Cartesian equation. Okay, so this is Cartesian equation for a line, for a straight line that we learned before. Okay, so to form a Cartesian equation, you need two. You need two information, right? The first one is you must have a gradient, and then the second one you must have a passing point lah. I call it as passing point because you need to know the coordinate. Alright, so you must know the coordinate of A, point A, then with the gradient, you can form the Cartesian equation. So this is what we learned before. Alright, okay, then now, instead of this Cartesian equation, for now, we are going to learn how to form vector equation. That means we are going to get the equation for this line also, but we will write in a vector form. So that's why we call it as vector equations. Okay, so to get the vector equations, you need also two information. Very similar to Cartesian equation, you also need two informations here. Okay, so the first one, the gradient. In vector, we will not call it as gradient. For me, I will just call it as direction of the line. That you want to find out the direction, which is the P or the B or any other vector. It is a vector form. It is a vector. Okay, so gradient here is a number. But the difference is because vector equation, so the direction of the line will be P, the vector. Okay, so gradient and the direction of the line have the similar meaning for vector equation. Okay, and then the second one, we also need the passing point. So the passing point, that means the coordinate of the point on the line, but we write in the vector form. So it can be A or it can be OA, the position vector of point A. So for these two equations, with these two information, when you try to combine them, your vector equation will be R equals to A plus TP. Okay, so this is a very important formula because it is a formula actually for you to form the vector equation. Alright, so you need two information here. Direction of the line is the first thing. The second thing is the passing point. And after that, you apply this formula to get the vector equation. Alright, so of course the detail and example, everything I will show you later. Okay, so maybe some student will ask how I know that R equals to A plus TP is a vector equation, is an equation that I want to get for this line. Okay, so we will have a look for the explanation in our notes. So let's say we assume that this is the line, right? And it is parallel to a vector P. So that means this line and this P have the same direction. Okay, they are parallel to each other. So we call it as the direction of the line. Okay, and then pass through a fixed point A. Fixed point A means this A, you already know the coordinate. And when you want to write into a vector form, it should be 1i plus 2j for this case. All right, okay, or we call it as any point A lah. Okay, so now to find the vector equation, that means you actually want to find out for this particular point on the line, but you don't know what is the coordinate. I want to know what is the general equation in vector form for this particular point on the line. All right, so you know that, okay, if R is the position vector OR, then R is a point on the line, which means AR. You see, from A to R. This point, this A to R is a direction also, right? This direction is similar to direction P because they are parallel to each other. But I cannot write it out as AR equals to P. It should be AR equals to TP because you learned the parallel vector before, right? If let's say OA and also CD are parallel, so we can rewrite as OA equals to lambda CD. So lambda is a number. So same thing happened here. AR and P are parallel to each other. So when you know that they are parallel to each other, you can write it as AR equals to TP. Okay? All right. So since you know AR is equals to TP already, you want to know how can I express the equation of OR, the vector equation, the OR. So to get the OR, it is OA plus AR. So if OR plus AR, OR is R, OA is A, then AR is TP. So this is the vector equation that we use to form the vector equation of a straight line. Alright, so that means this R is actually the coordinate of a point on the line. Okay, and then the whole equation here, that means that because the R can be somewhere here, can be somewhere here, can be somewhere here, or here, or here, or here, right? There are many points on the line that you don't know and you want to find out. So in general, this equation can, can represent by using the whole line, the point, the dots of the R on the line. All right, so this is the explanation. So I hope that maybe you can spend some time and try to understand it. But of course, I will explain also the concept in a more detailed way in the example later. All right, so for now, this is the important thing. First, you must know what is the direction of the line and what is the passing point before you want to form the vector equation of a straight line. So to me, this is the important part that you need to know how to apply. Okay, all right, so if we continue further, then let's see what else explanation we have. Okay, so here they said the equation R equals to A plus TP is known as vector equation. So I told you vector equation is a keyword. And then for each value of the parameter t, this equation gives the position vector of one point on the line. So as what I mentioned, the t here is a value. Okay, but you don't know the value yet. But if let's say you substitute any value here, that means it represents a point on the line. So I will explain this to you later by using some example. Okay, so because of the t can be any value on the line, right? So can be any value, then you can get a point on the line. Therefore, when all the points are gathered together, you can see that you can actually get a straight line. All right, so we call as vector equation. So A is the position vector of any point lies on the line. So I call it as passing point. So in the explanation later, I will also use A as a passing point. That means a point that you already know, which is on the line. Okay, that means but it can be many different values. So that means the equation of line is not unique. So this one we will also discuss it further in other example. Alright, so for me, before we proceed to the example again, just want you to recall back. This is the most important thing. First of all, before you want to form the vector equation, you need to have the direction of the line. First thing, and second thing is the passing point in the vector form. Both should be in the vector form. And then to form the vector equation, you need to remember this formula, which is R equals to A plus TP. T should be a number, but you still don't know what is the number here. Okay. Right. Okay. So we will start some discussion here. For example, 13. Okay, so this is a basic example, but we can try to discuss and then you try to understand the idea. Okay, so first of all, let us have a look. Okay, for this question, they want to find vector equation. So this is a keyword, vector equation of the line that pass through the point with position vector. So pass through the point with this position vector, which means this will be your passing point. So for passing point, you can write as A or you can write as OA. Okay, and it is parallel to the vector of this one. So when you see that it is parallel to this vector, that means what? That means this is your direction of the line, so which is the P. Okay, so for first part, to form the vector equation, it is very, very simple, which means that R is equals to A plus TP. Okay, so R is equals to A. A is what? A is 2, negative 1, 4, plus TP. P is 1, 1, negative 2. Okay, so your vector equation will look something like this. Okay, so you can see that A is a passing point. P is the direction. So the direction of the line should be parallel, okay, with the straight line. Right, that you want to find out. So this is what we have as the answer. Okay or not? Right, so you can see that I write my answer in this form, and this is what we call as column vector. But in exam, they might give you the vector equation in others form. So as an example, you might also see that they give you the answer like this. R equals to 2I minus j plus 4k, then plus d, then I plus j minus 2k. Okay, so this is also the same answer, but they write out in IJK form. Can see that? Okay, because this one is actually coming out from here. The 2I minus j plus 4k. T, you just copy as T, multiply with the column vector 1, 1, and negative 2. So when they write out the answer like this, you have to understand, oh, this is also a vector equation. For me, I prefer to write out in this way because later when I want to do any calculation or any solution, to me, I think this form is easier for me to look at it clearer. Usually for me, to me, this kind of equation, it is quite confusing or maybe too long, I don't like. So I prefer this way. But no matter which one you write out, they are still the same. They are still correct. Okay, so we got another version. So or some of the answer, they will give you something like this. R equals to 2 plus Ti plus negative 1 plus Tj, then plus 4 minus 2tk. This is also correct answer. Okay, so can you see it or not? How can I get 2 plus t? So you see 2i and also 1ti, right? So they group them together, become 2 plus t, then I. I hope that you can see that. So how can I get the negative 1 plus t? So you see here you got negative 1j plus tj plus 1tj. So negative 1 plus tj. Can see that? So this is how they group it. Also in the component ijk, but they rephrase everything. Right, separate it. So for all these three answers here, all of them are correct answer for vector equation. So I hope that in the future, when you look at the marking scheme, or maybe you look at some other solution, at least you understand all the three answers here are actually the same equation. They are all for vector equation. Okay, just that they write it in different patterns only. Okay, all right. So this is what we have for the very first example. Okay, all right. So let us continue to part number B. Okay, so if let's say you roughly have the idea how to do it, maybe you can pause the video here and then you try to write out the answer on your own. Okay, so let us continue. Find a vector equation. So again, you see the keyword vector equation for the line that pass through the point. So again, this is the passing point. Okay, so but they give a coordinate. So to write out the passing point in a vector form, so it is what? You assume that it is a position vector. So 2, 3, and negative 8. Okay, or 2i plus 3j minus 8k. And then parallel to this vector. So this vector will be your P. So again, this is not hard at all, right? Okay, so for me, my answer should be R equals to A plus TP. So the P is 5, negative 10, and 15. Okay, so this is my answer for this question. Alright, so I will write it out in this form. Okay or not? And then if you are interested to write out in all this, you can practice by yourself. Okay, so for me, I will just write out in this form. Okay, so for this example, there are something worth for us to discuss also. Okay, so besides this pattern, this as a final answer, it is not wrong also. You can write it out as this R equals to 2, 3, negative 8 plus, maybe I use another value S, S, and then 1, negative 2, and 3. This is also the correct answer. Okay, so can you compare what's the differences between these two questions? So you can see that for these two, for these two answers here, they actually try to simplify this direction. Okay, so they take out the 5. They factorize out the 5, so become 1, negative 2, and 3. So when they take out the 5, right, 5 multiplied with t, it is still a number. Alright, so I can substitute by using s or any other letters that you like. Okay, but you need to know that s is actually 5t. You can simplify it like this. Okay, so this is another example. So which is the correct answer? Both also correct. Just like usually, if let's say you can, people will prefer to factorize out the direction. Okay, so to simplify the vector, right, there's also something important. Only direction, the TP, direction P, can be simplified. Okay, so what's the meaning? The meaning is this one, passing point. You cannot simplify it. When you want to get the answer. Because if you simplify the passing point, that means it is other passing point already. So other passing point doesn't mean that it is also lies on the line. Okay, but for the direction, yes, can. Okay, so this is another extra adding point to let you know. Okay, when you want to form the vector equation, so this is how we get it. Okay, you can simplify the direction P, but you cannot simplify the passing point A. If let's say this is 2, 4, negative 8, you cannot simplify. You have to keep it the original way as it is. Okay. All right. So you see example 1, you have some extra information here. Example 2, also some extra information. So now we proceed to example C. Okay. So now I want to discuss the example 13 part C. All right. So now they want you to find the vector equation through for the line through this passing point and also parallel to the y-axis. So for this kind of question, maybe you can maybe try to draw a figure to help you all right, to understand better how the line look like. All right, so they already tell that this is a passing point 3, 1, and it is parallel to the y-axis. So when you're having a line parallel to y-axis is something like this, a vertical line, okay? And then since they tell you that it passed through 3, 1, it means that this line passed through the point 3, 1. This is 3, 1. Okay? Then since this is 3, 1, so that means this coordinate is 1, all right? The y coordinate should be a 1. And then the x coordinate should be a 3. So this is x equals to 3. All right? Okay, so if you look at this diagram, generally for this line, you will see that no matter where is the point, what is the coordinate that you have on the line, the y is always the change one, the value that change. And then the x is the value that always fixed. So as an example, if let's say I'm asking for this coordinate, so you should know that the coordinate should be x and then some other value for the y. Okay, so that means now the value of y change, but the value of x is fixed. Therefore, when you want to write out the direction for the line parallel to the y-axis, it should be 0 because the x is always fixed. That means the x is not moved. The value of x is not changing. Right? Only the value for y will change. So you can write the value for y with any value. It can be 3, it can be 4, it can be 5, it can be 6. But usually for me, I want to make it the most simplest one. So usually I put it as 1. Alright, if you put it as k also no problem. You want to put it as 5, -3 no problem, as long as there's a value for the y. Because the value of y will change. But the value of x should be always 0 for the direction because the x will not change. It is always fixed for this kind of question. Alright, so that means I have the passing point, which is 3, 1. I have the direction of the line, which is 0, 1, when your line is parallel to the y-axis. Therefore, when I want to write out the vector equation, should be OA. So my OA will be 3, 1. Okay, then plus TP. So what's the P here? The P will be 0, 1. Right, so this is the answer, actually. Okay, so this is what we have for the vector equation for part number C. But at the same time, again, I also want you to understand, right, what is the value, what's the meaning of this vector equation if, let's say, I substitute some value into the T. Okay, so this part is for explanation and just to let you know how we actually interpret the value or interpret the vector equation here. Okay, so if let's say when T equals to 0, when you try to substitute the T equals to 0 into the equation, you will get R, which is equals to 3, 1. Okay, so according to the line here, so maybe I draw it again. Okay, so according to the line here, this is what I have. Wait. Okay, so this is the line that I have parallel to the y-axis, right? So when t equals to 0, I'm having this point, and this particular point is 3, 1. Alright, so if let's say I substitute the value t equals to 1, so what do I have? R is equals to, you substitute 1 into this vector equation, so 3 plus 0, you get a 3. 1 plus 1, you get a 2. Therefore, for this coordinate, the point will be 3, 2. So 3, 2 means it will be somewhere here. Okay, so this is 3 and this is 2. Alright, and then if you continue further, how about if I substitute t equals to 3? So the r will be equals to, substitute 3 into this equation. So you're having still 3, then 1 plus 3 become 4. And therefore the point 3, 4 will be on the line as well. So maybe 3, 4 is here already. So this is 3, 4. How about if let's say I substitute in negative? Let's say I substitute negative t equals to -1 or maybe -2. What will happen to my coordinate? What will happen to the vector equation here? So for this vector equation, when you substitute t equals to -2, you have 3 plus 0, which is still a 3. And then 1 minus 2, you will get -1. So from the graph here, if you look at the coordinate that you get, when you substitute the value of t, then this particular point will have the coordinate 3 and -1. So from here, you can imagine that if you continue to substitute all the different value for t, right, the points that you get will be always on this particular line. And when you have a lot of different points on the line, eventually it forms a line, a different point, then eventually it forms a line. So that's the meaning of the vector equation. When you substitute the value of t itself, it actually represents a point on that particular line. Alright, so it becomes a coordinate when you substitute the value of t, a value for t. If let's say you don't substitute the value of t when t is general, then it actually is a line equation. Understand what I say or not? Alright, so I hope that you can understand. Alright, how we get all the coordinate from the vector equation that you form. Okay, so this is what we have for the vector equation and also the meaning of that particular vector equation.